All right, welcome to part two of chapter six, Human Population Dynamics. We're going to get into the next section dealing with more developed countries versus less developed countries in the world, taking a look at economics, standards of living, population pyramids, the demographic transition model, uh, future population growth, strategies for managing population growth. So as we begin, let's take a look at some review of some basic econ terms that we talked about earlier in the year. We've got GNP versus GDP. So GNP is gross national product, and this is the sum value of all the goods and services produced by a nation in one year. So GNP does include all the companies owned by a nation's citizens, whether they're operating within that country or abroad. An example would be a factory producing Ford automobiles in Mexico. It would still contribute to the GNP of the US, but not the GNP of Mexico because Ford is an American owned company. GDP, on the other hand, is the sum of all goods and services produced within the borders of a nation in one year. So, looking at that same example, the Ford factory in Mexico would actually contribute to Mexico's GDP and not the United States' GDP because those products were produced on Mexican soil. When we talk about per capita, we talk about that meaning per person. So calculating per capita GNP or GDP, it allows us to make a comparison of larger nations to smaller nations in terms of their economic productivity. The U.S. GDP is the largest of any nation. It's over $15 million billion every year. However, if we calculate the per capita GDP, the U.S. really just kind of barely makes the top 10. Small nations like Qatar and Liechtenstein are more than twice as high in terms of per capita GDP. Now, when we look at standard of living is related to per capita consumption. So, in general, nations that have a greater GNP and GDP will have an overall higher standard of living for their citizens in their country. There are some cases where a widening wealth gap, though, between the wealthy and the poor means that a minority of people are extremely wealthy and the majority of people are living at a much lower standard of living. So let's get into talking about population pyramids or age structure diagrams. We've done some work on this earlier in the year. One of the things I can tell you about these things and their appearance on the AP exam, they're one of the most common things to appear on the AP exam. So make sure you know how to interpret these in order to predict the relative rate of population growth and what level of development corresponds with each type of age structure. I'm sorry, let me go back. All right, so what we're looking at on the left here for the Democratic Republic of Congo is we're looking at an LDC, less developed country. These LDCs tend to have more young people, fewer elderly people. They've got high birth rates, high infant mortality, have a higher young adult mortality because of political and social conflict like war or genocide. Basically, what we're looking at here on the left with Congo is it shows rapid growth. It means it's really, really wide at the bottom, indicating a young population, with each succeeding age cohort's bar being significantly shorter than the one below it, which indicates high mortality rates at all stages of life. Um, More developed countries, however, like the one in the middle and the one on the right, the US and Germany, they tend to have aging populations with lower birth rates, low infant mortality, and they do have slower population growth. In some cases, even negative growth, which we'll get into in a second here with Germany. With slow growth, the US and most of Europe, there's moderate population growth between 0.5 and 1% every year. Age structure diagrams for these countries tend to show more balanced numbers among all the different age cohorts with a slightly wider base and a slightly narrower peak. Zero population growth, basically, you find countries in a state where their population is not growing at all. The population pyramid for this would show all of the different age cohorts approximately equal, so straight sides with no slope. There are very few countries right now currently at zero population growth, but there are lots of more developed countries that are actually approaching this state. And then finally, here on the right, we see a population pyramid for Germany. Nations like Germany, Italy, Greece, they're actually undergoing negative population growth. So the age structure diagram for this, you'd have it smaller at the bottom, indicating a very low birth rate, larger in the middle, and at the top. Basically, it kind of looks like an inverted pyramid. Um, Something to consider with more developed countries versus less developed countries. Although about 80% of Earth's population does live in LDCs, these people consume only about 20% of the resources on Earth. 20% of the population resides in MDCs, but that 20% of the population is actually responsible for 80% of resource consumption. All right, moving on to demographic transition. This is the process basically where the population of an LDC starts to reflect the developmental changes that take place as that country moves toward a state of greater economic development and stability. So you could probably see demographic transition graphs in two different ways. In this way, where it just shows population pyramids, and then there's another way we're going to go over here in a minute, where it actually shows a line graph of birth rates, death rates, and overall population. So what we're looking at here, if we look at stage 1 on the left, this is the typical pyramid for an LDC. It's got a high birth rate, high death rate at all age cohorts, and we're dealing with a really short life expectancy. Stage 2, as a nation becomes more economically developed, the death rates are going to fall. So because of better health care, better sanitation, more stable diets, the infant mortality rate is going to decrease and life expectancy is going to begin to increase. So the birth rate is still going to be pretty high, but you're going to have a larger population at all of those different age cohorts. We move into stage 3. The nation is going to continue to progress in its economic development. It's going to continue to be more stable. It's going to improve education. Medical care is going to improve. All of this is going to lead to a decrease in birth rates. At the same time, you're going to have more people living longer because of the reproductive time lag caused by longer human lifespans. So the population will continue to grow even as birth rates decrease. And then finally, we get into stage 4. The birth rate continues to decrease, and then it winds up leveling off with higher levels of education and healthcare availability, especially for women. The population will continue to have an older mean age, and eventually this is going to lead to a stabilization of the population to a point of much slower or zero or even negative growth. That negative growth will be late in stage 4. After many, many decades of a stabilized economy, you can actually begin to see declining population sizes. Now, this demographic transition model basically explains in line graph form what I just talked about, going from stage 1 through stage 4. Stage 1 is what we saw with an expanding population. The population pyramid can be found down here underneath. Very wide base, very narrow top. You've got a high infant mortality, high birth rates, high adult mortality. And then as we get into stage 2, stage 3, stage 4, the increasing industrialization, increasing stability, increasing economic development as we go from left to right. On here, the red line is the death rate, the green line is the birth rate, and the black line is the overall population. So as we can see during this expanding and late expanding time periods, where we see a lot of our less developed countries right now, their population growth is off the charts. It almost looks like a J-curve for exponential population. And then finally, in that late stability stage 4, you can see that the population will actually stabilize and it'll balance itself out and eventually approach negative population growth. So one of the things you need to make sure that you're doing is you need to make sure you know exactly how to read this graph, because this is actually one that's commonly used on the AP exam. All right, projected future growth. As we attempt to predict how the population will look in the future, it's expected that African and Asian countries will have the greatest rates of future growth, except for China, of course. China is that exception because of its one-child policy, its strong social pressure. As we saw earlier, China's population growth has been steadily falling since the 1980s, and it's now around 0.5%. So what we're going to do is we're going to look at a couple of different countries and areas, strategies for managing population growth, and kind of what has happened there. We're going to start off with India. India was the first large nation to recognize the need for family planning, education, and birth control all the way back in the 1950s. At that time, India really had difficulty successfully implementing its population control programs because, one, it's a very ethnically and culturally diverse nation. many languages, many ideologies represented. So it was difficult to inform and convince citizens to follow any single national plan. Two, culturally, Indian people tend to value male children, leading many women to continue having children until one or more males were produced. Many Indian people also value very large families, further driving the total fertility rate even higher. Um, since the 1980s, though, India's family planning, education, and birth control campaigns have been much more effective in reducing its population growth. But as we saw earlier, its population growth is still it's 1.5%, so it's still a rapidly growing country. Let's talk about China. Realizing its population was outgrowing its natural resources, as we talked about earlier, China enacted a strict population control called the One Child Policy, and this started in 1979. People who pledged to limit their family to one child, they received benefits, access to better jobs, education, even food. The policy, however, only applies to urban areas. It's accepted that more children could be needed in rural areas to provide labor and support for farming families. The one child policy has been successful in dramatically decreasing the population growth in China, so much so that it was recently modified to allow a second child in families where both parents were an only child. And the drop in population growth has had some negative effects, though. People worry that there will be too few young people to fill job vacancies as people retire, and there will be a shortage of caregivers for the elderly. There are also ethical issues involved in governmental control over reproductive rights, which is an entirely different discussion, which we can certainly get into at some point. Let's take a look at Western Europe. Western Europe, as we talked about before, lots of places undergoing zero population growth or even negative growth. Some of them are finding that their population is either approaching zero or declining. While this is good from an environmental standpoint, there are some economic concerns associated with zero population growth. In countries with zero population growth, the demographic pyramid tends to show an aging population with fewer individuals in the younger cohorts. This could lead to shortages in caregivers for the elderly. It could lead to there being not enough qualified workers to fill vacancies caused by retirement. So while environmentally speaking and resource use speaking, it's a good thing to approach zero population growth, but economically speaking, it might not be. And then finally, the U.S. As we know, the U.S. is a world economic leader, and it's considered to be a more developed country. So it's expected that the U.S. would have zero or even negative population growth like the other MDCs, but that's not the case. The U.S. has a pretty unique set of demographic patterns because of a number of different factors. One, among middle and upper class Americans, there's a trend toward marrying at a later age and having fewer children, which is typical of most MDCs. Two, because of a growing wealth gap, there are also a lot of people living in poverty who lack adequate health care, they lack education, they lack financial resources to be considered members of the middle class. For this portion of the US population, the women do tend to have much higher birth rates. So as a result, population growth is much higher. And unlike many MDCs, the US has always had a proportionally large number of immigrants, both legal and illegal. A large portion of immigrants to the US come from LDCs. In most cases, these immigrant groups show similar demographic trends to those seen in their home country, at least for the first generation or two after coming to the US. So marrying younger, having larger families, that drives population growth among many immigrant groups much higher than the US national average. So you take all these things into account, the US tends to have a percentage population growth that is higher than the average MDC, but lower than the average for LDCs. As we saw in an earlier example, its population growth rate right now is 0.97%. Well, most of the MDCs are approaching zero population growth or even negative. India's population growth rate was 1.5%. So again, because of all of these factors in the US, we are actually seeing pretty rapid population growth in the United States. All right, I said that I would put this up Again, this is one piece of the assignment that's due on Thursday, January 29th. You got some math practice. Remember, you're not allowed to use calculators on this math practice. You're not allowed to use a calculator on the AP exam, so let's do all this stuff by hand, please. The first couple deal with the rule of 70. So you've got some figures here dealing with the rule of 70 and doubling time. And then down here, these two deal with growth rate. So we're dealing with crude birth rates and death rates, and you got to figure that stuff out. And then finally, there's a free response question that also deals with math that's also due on January 29th. You can access this on the Google site. There's a link to the file underneath the two videos. If you can't find it there, you can also access it on the forums and docs page, which is linked on the left-hand side of the Google site. So I will see you guys in class on Thursday.